Hello and welcome to SenseLab at the Yale Center for Medical Informatics. You can access the SenseLab suite of web resources by typing senselab.med.yale.edu in your browser. What we're going to do today is look at three databases which are related to the sense of olfaction, and those are ORDB, OdorDB, and ORModelDB. So ORDB is a resource that stores genomic and proteomics information related to olfactory and chemosensory receptors. OdorDB is a resource that stores information related to odors, and ORModelDB is a resource that stores information related to computational models of olfactory receptors and other chemosensory receptors, typically those that follow GPCRs of type A. What we're going to do is look at a brief introduction to each of the resource with a little introduction as to how to use these three resources, and also what we're going to look at is how these resources are integrated. So let's start with the olfactory receptor database. So you click on the olfactory receptor database, and what you'll see here is this is our homepage, and you'll see that there's links related to human olfactory receptors, mouse olfactory receptors. This is a sequence analysis, sequence comparison exercise that we undertook a few years ago when the human and mouse olfactory receptors were mined from the human and mouse genomes. So using this is not going to be part of this video, but you can click on this and you can see the sequence comparisons from different resources. What we're going to do typically is look at how to use the olfactory receptor database, what kind of information it provides, and also this new search feature which allows you to leverage the different attributes in order to narrow it down to the receptor that you're looking for. So let's start by going to enter ORDB. And what you'll see here is the information is stored in a certain hierarchy in the olfactory receptor database. And that's called the EAVCR, Entity Attribute Value, with classes and relationships. So you see here the different classes that are available. And for each of those classes, you'll see how many entries are there. Now, over the last close to 2 decades, the olfactory receptors that we have risen from about 1,000 entries to close to 14,500. And you'll see that they represent information that has been submitted by users, but also has been mined from 6,500 GenBanks. It represents the work of 135 different labs. We'll look at what OR names are, and it also represents the publications from close to 500 publications, 81 different strains, receptors from 36 different tissues, and of 4 different types. You can find out something more about a class, but if you click on the number, it takes you directly to the entries. So I've clicked at 14,450, and what you see here is information. For example, you see CECR1, then there's a pipe, and then there's ODR10. This is C. elegans, chemosensory receptor 1. This is the ORDB nomenclature. Now, the ORDB nomenclature does not follow any specific method. It's chronological. So when you have CECR, it says C. elegans, chemosensory receptor 1. These have been numbered in the order they have been entered into the database. What you see on the other side of the pipe, for example, here you see ODR-10 is the name given to that particular gene in the lab in which it was either discovered or cloned, etc. This is important because we understand the ORDB nomenclature, but very often people are looking for receptors based on the common names. There's more than 10 pages of these, and you can see there's 40 per page. Now, if you clicked on Show All, you would probably get all the chemosensory receptors, and that's kind of an extensive list. But let's just randomly click on one. I'm looking at CECR11, which is a C45H4.15, and this is the kind of information you're typically going to see. So this is the name that we give it, the CCR11. As you can see, it's C. elegans chemosensory receptor. It was the 11th C. elegans receptors. The reason why we decided not to call it OR type, for example, is because we decided that there were different kinds of receptors in the chemical senses, and you would find one of these is OR, and we'll look at that again. So it tells you that it comes from C. elegans. It tells you it comes from chromosome 3. This is the GenBank link from which it was mined. This is the PubMed link for this particular paper. And while we mined the information from GenBank, this came from the labs of Donald Wilson. Okay, so Donald Wilson is stored in here. It's a full-length sequence, and you can see the nucleotides, for example, here. You can see the amino acid sequence here. It tells you that it came from a genome project. It didn't come from a cDNA. It has a SwissProt, or now XPazy link. There's no model available for it, and there's no microarray available for it, but you'll see that these attributes are important because they might actually be populated for other receptors. To put this particular entry in the perspective of the database schema, so the olfactory receptor is stored as a class, okay, or an entity. Now this entity has descriptors or properties which are called attributes. So all these are attributes related to this particular entity, and these, the values, so that's the EAV, the entity, the attributes, and the values. Okay. Now you'll also realize that some of the information, bits of information here, are also stored as entities. The reason why some information is stored as entities is because what happens if this information has to be repeated? What, for example, if there is another resource which comes from the same GenBank entry? Well, we don't want to keep entering these information as entries again. Now, if you click on show for any of these which actually have show, you'll see that this information is stored as an entity. It has its own attributes. Now this is not very well populated, but that's fine. And for that particular attribute, that is the name, we have a value. Okay, and you'll see this very clearly in the case of, for example, Donald Wilson is stored as an entity, because if there's other receptors that came from the labs of Donald Wilson, then we don't have to re-enter that information. So if I show Donald Wilson, so Donald Wilson is the entity, and so what you're going to see is these are the attributes for the entity Donald Wilson, and so these are the values. And one of the reasons why for the sequence lab, or the leader of the lab from which that sequence came, the reason we have this is because we want ORDB to also be a kind of a community setting where people can communicate with experts and share information. Now, what you'll see in Sequence Lab is also show other. So if you show other, you'll get a list of all the other olfactory receptors or chemosensory receptors that can be attributed to the labs of Donald Wilson. So if I click on CCR104, you'll see that that also belongs to the lab of Donald Wilson. Okay, and this is one way in which the EAVCR, the database schema, allows information to be integrated properly or more efficiently. If, for example, you click organisms and you show other organisms, it's nothing novel here because all these are C. elegans. So all other receptors in ORDB that have been attributed to C. elegans. This is the kind of information you expect to get once you come to olfactory receptors. And here, for example, you can look at the other organisms too. So, for example, if I click on the number, remember, always click on the number, and the number will tell you all the other organisms that are represented here, and there's 70 of them. You click on labs. The work of 135 different labs have been represented here, and you're going to see, and you can see all of those. So, for example, because we know that Bonner is an entity, you'll see all the attributes and all the values. So this is from the work of Tom Bonner, and you'll see his affiliation and his email. Okay, and this is typically how this information works. We looked at organisms, we looked at sequence labs, the different types of tissues. These are different. Again, GenBank is just going to give you a link to the GenBank. So even if we click on this, it'll tell you what the information is. Search. Now, because there's 14,450 receptors in here, how do you search for the one you want? And one of the ways you can do this is by using filters. You might say, well, I want everything that has to do with mouse. And one of the ways in which you can look at this is you say, I have attributes, right? So I have all these attributes, for example, chromosomes. One of the attributes is SenseLab. One of the attributes is what type of sequence it is. Or one of the attributes is what's the PubMed ID. So if I know that particular PubMed ID, I can go in and put that PubMed ID and I can find all the receptors that are ascribed to that particular ID. So let's say, for example, because I know this database, I say I'm just going to go with the name and I'm just going to call it OR11. So this is one of the earliest olfactory receptors determined. And if I click on search, now the search results here are in different forms. Okay, you can get an HTML, XML text, or even just basic text. But if I say, let me click on HTML, and if I click on OR11, I get OR11. This entry is, it's the olfactory receptor like. It's ORL11. It's an olfactory. Remember the previous one we saw was C. elegans, so it was CECR. This is ORL. And the reason why we call it olfactory receptor like and not olfactory receptor is because we realize that these have been found in different tissues, including things that are remote from the olfactory processing centers, like the skin or the liver. And therefore we said, let's just call it olfactory receptor like. And you'll see that this comes from rat. This comes from the olfactory epithelium, which is a tissue. It's on chromosome 11. There's a GenBank entry. So if we click on the GenBank entry, it'll actually take you to GenBank and you'll see that particular GenBank entry. Okay, you can click on PubMed, the PubMed link, and it'll take you to the link for that particular paper, which is one of literally the first paper which actually talked about the discovery of an olfactory receptor in that Cell paper by Buck and Axel. So you can see the information for Richard Axel and Linda Buck. It tells you its full length. It tells you that 2 ligands have been, or odorant molecules have been shown to activate this particular receptor. It tells you the nucleotide sequence. It tells you the amino acid sequence. It tells you it came from a cDNA. And we do have molecular models of this, and we can look at that later. We also know that there is functional analysis done on this particular receptor, and PubMed for this functional analysis of this particular receptor. And a molecular model has been seen here. And it's also part of a microarray experiment. So this is another description of the olfactory receptor. So now this is OR11, but I knew that it was OR11. So what if I needed to look for OR11? So one of the things, I could go back to the search and I say, let's say I don't know the name of this. But if I click on new here, I say, okay, I know it came from the rat. What you see here are all the attributes. So I go to organism, and if I hit the lookup table and I just start typing rat, the program knows that it's the binomial name for rat. Now if I search for rat, I'm going to get a lot of things. So I go to the chromosome attribute and I say, look up chromosome 11. Remember, the aim of this is to show you how you can use the attributes as filters to narrow down the number of receptors. And if I click on search, how many do I get? Well, I get quite a few. Remember, this is the one I'm looking for. I want to narrow it down to this OR11. Now I know it came from the lab of Linda Buck, so I go to SenseLab and it gives me a lookup. And if I say, it'll tell me who that person is, and I click select, and so it comes from Linda Buck. Let me see if I've narrowed this any. So I can actually say that I got this. Click on OR11, and this is exactly what we saw. So we can go back one. It tells you it came from rat. Now notice that's the information that it's trying to kind of give you. Okay, so if I say, well, I know that this is how I can narrow it down to OR11, and I know it comes from the rat, it's chromosome 11, and this is a SenseLab. Now if you look at this, these are exactly the attributes that I used to create this particular filter. But what if I say, well, I know I want a name, but I know it's from rat, I know it's on chromosome 11, and I know it came from the labs of these people. I don't want to see that information. So you might say, okay, click off, and click off. And so if I do the search again, it'll just give me the information I want. But without having to go into this particular link, if I say, I want to find out what the protein sequence is. Okay, if I want to see the protein sequence, so I can click, for example, on amino acids, which is up here. I can click on amino acids. But now remember, there are tick marks on this. That's all I'm going to see. Okay, and so I hit search, and I'm going to get the protein sequence. Okay, and that's so you can get the nucleotide sequence also. Now, if you say, well, I want to redo this search, but I don't care about this particular chromosome, so then you can always click that particular thing off, okay, and if I say, we know the sequence labs, I don't care about the organism, so now we're probably going to get a bigger list. So if I click on this, what you're going to get is a lot of the protein sequences of a lot of the receptors that come from the labs of Linda Buck, and that's how the information is stored. From her lab, you have a lot of olfactory receptors. We have vomeronasal receptors from the vomeronasal organ, some more olfactory receptors. We call these the TPR, taste papilla receptors. And so you see there's about 107 receptors that are in ORDB, which came from the labs of Linda Buck. What happens if I say, well, yes, we get some taste and vomeronasal receptors, but let me filter this down and say, well, I only want vomeronasal receptors. So that's the CR type, and now we'll have a lookup here. So if I type in V and R, which is vomeronasal receptors, and I select that, so now I've added another filter. So what I expect to get is the amino acids and the name from the labs of Linda Buck, but these I only want vomeronasal receptors. But I know they're vomeronasal receptors, so I don't want to necessarily be told that they're vomeronasal receptors. So I click on search, and I only get the vomeronasal receptors, and you see there's 29 of them. Okay, so one of the good parts of using the attributes to create these particular filters is that you can, every time we add a new attribute, so we say, okay, now we need another descriptor. That descriptor is useful for a chemosensory receptor. That particular attribute automatically becomes another filter to narrow down searches in ORDB. So now let's go to OdorDB. Okay, so again, we are looking at SenseLab, and it takes us to OdorDB, and we click on OdorDB. Now this is a smaller resource. Now remember, OdorDB is not a repository of all odors or all organic molecules ever. This is information that is strictly odors that have been known to interact with olfactory receptors. Okay, so for example, if I clicked on data, and I saw that that odors are classified based on cyclic structure, what their functional groups are, what the nature of the hydrocarbon is, and if I click on 6, it'll tell me whether it's a benzene ring, it's a branch chain, it's cyclic, there's a double bond, there's a straight chain, there's a triple bond, etc. And this is the third part that's really important, and we tell you that these are odors, and if you click on the number, as usual, you click on the number and you get all the odors that are part of this resource. And I think there's about 257 of them. Now, again, these are odors that have been known through functional analysis to activate or inhibit or in some ways interact with olfactory receptors. Let's go back to odors for a second and look at, for example, 2-octanone, for example. So what you'll see here is what kind of information will you get about the odor? Well, you'll get information. This is the name. There's nothing in the description here, but this is the chemical abstracts number. This is the molecular formula. It tells you there's a functional group. It tells you it doesn't have a cyclic structure. It tells you it's typically a straight chain, and here's the two-dimensional structure. This particular link is really important, and what this link is it tells you each of these odorant molecules which serve as ligands to chemosensory receptors. This is where we see the integration between ORDB and OdorDB. So remember, in OdorDB we call these odors. In ORDB, these are ligands. Okay, so when you look at that ligand attribute, for example, for ORL11 it was octanal and heptanal. These are the odors in OdorDB, and this is kind of important. So for example, we look at plus carbone, and you click on number, and you see all the receptors in OdorDB are known to interact with carbone. So you can click on that link. It'll take you to the ORDB entry, and this is how OdorDB and ORDB are integrated. Okay, and so this is your typical ORDB. Obviously, this is a receptor which comes from mouse. And again, you can look at the PubMed. It tells you what the strain of the mouse is, and it tells you the common names. And let me just tell you about the common name. If, for example, you clicked on the human and mouse ORs, so this is a nomenclature given by the lab of Stuart Firestein when they mined mouse ORs from the Celera resource, and this is a name given by by the labs, by the people in the labs of Barbara Trask when they mined the information. And obviously, this is in terms of functionality, it's a well-characterized receptor. This is kind of a very important link. The OR by ligand is an important link because it tells you, for every odor, which receptors have been known to interact with it. That is about as much as I will talk about OdorDB. And if we go back to the SenseLab resource, let's click on the last one, and this is relatively new. And you go to the olfactory receptors model database, and we look at what these models are. So you click on model, and you see that this is relatively scant as far as its information is concerned, but it largely represents the state of this kind of work. And for example, you'll see that there's 8, and there's a lot more. But the good part about all of these databases is that the infrastructure does exist to rapidly populate when necessary. So we'll just go to one of these. This is the URL, the ORDB link, the ORL 3137, and this is the common name given to it by the lab where this was cloned or identified. So let's click on this, and what you see here is this is the information that you typically have. It tells you it's the OR model. It's the OR model 2 because it's the second one entered. It tells you there's a GenBank. So if we click on GenBank, it will open the GenBank link for this. Okay, so there's one way in which it integrates with its source. There's a PubMed, which will take you to the PubMed link. And it tells you that this is a chemosensory receptor. These are the other common names that were given. This comes from the HORD database, which is adopted by Hugo. This comes from the Synomics work on mining olfactory receptors from the genome. And this comes from, I think, the European Bioinformatics Institute, the EBI. And so there's others like other names which are similar olfactory receptors, and there's the link to the PubMed of the computational work that was done on this receptor. This comes from the Weizmann Institute. What else do we see? We use the JMOL where you can actually see this particular receptor, the modeling work done. And again, those of you who know and you can use JMOL, you see if you right click on it, you can get all kinds of ways to visualize this. Typically JMOL is what is being used in, and there's some other viewers too, in PDBs, and you can actually manipulate within the web. Now remember, there is no crystallographically determined structure of an olfactory receptor. So these models are typically computational, and because they're computational, you will see that there's different notions and ideas that go into creating a model. And because we want people to be really interested in sharing models, sharing ideas, working on refining models, etc., what we've also done is included the PDB file. And this is how one way we can share models. The ORModelDB integrates with other olfactory receptors, and for example, if this model was associated with a ligand, then you would get you would get the name of the ligand, and once you got the name of the ligand, that would incorporate with OdorDB. So let me look for one where there is a ligand. So MOREG, does it have a ligand? Yes, it does. And if you click on that ligand name, you will actually go to the information of that ligand in OdorDB. So you see that each of these databases, as they're developed, they will integrate with ORDB and OdorDB. We do allow users the facility to get an account and put their own information, and they have the option of keeping it private for a while, until, for example, a publication is out, and after that we recommend that they share it. If you have any questions, please contact me at chiquito.crasto@ttu.edu. I'll be happy to help with this, and I hope this has been instructive. Thank you very much.